Hello everyone, and welcome back to another Study Shed video. Today, we'll be going over the topic of solving first-order linear differential equations using the method of substitution. In the past, we've solved differential equations in this form. dy over dx is equal to something like xy. And the way we've been able to tackle problems like these is we'll use something called separation of variables in order to bring all the y's on one side and all the x's on one side. In a problem like this, we'd do something like dy over y by dividing both sides by y, and then we'd multiply both sides by dx to get x dx. And then this would work because we could just integrate both of them by treating dy and dx as variables of integration, and this would be really easy to solve. However, if we were to have a problem like this, dy over dx minus x minus y is equal to 0. It's actually, for the measure, we'll make this we'll make this y in front equal to 0. Well, now we're in a problem here. We can subtract the x and y to the other side and get y dy dx is equal to x plus y, but that doesn't really do anything. So how will we go about doing this? We need to do something, the method known as substitution. And the way this works is, I'll rewrite this problem to make it more solvable. We'd have y dy dx minus x minus y is equal to 0. And we'd want to try to make a substitution. And most of these substitutions have both variables x and y. So the most common substitution that's normally employed is the substitution v equals y over x. And so we'd want to introduce a y over x into this problem. The most easiest way we could do that is to divide the entire equation by x. So you get y over x, and for the sake of not writing dy dx over and over again, I'm going to write y prime minus 1 minus y over x is equal to 0. And here we can make our substitution. V is equal to y over x. So using that substitution, we get vy prime minus 1 minus v is equal to 0. And the goal of using such a substitution as this is to make the equation separable. As you'll see later, every time we use a substitution in this form, this equation will become separable. However, we'll run into a problem here. Our equation is only in terms of v's and x's, as we've defined v to be a function of x. But we have a y prime in here. So we need to somehow turn that into v's and x's. So how we would do that is, in our substitution over here, what we're going to do is we're going to cross multiply the x over to get y is equal to v over x. And now we're going to take the derivative implicitly of y. So we get y prime is equal to v. Using product rule, we have v times the derivative of x, which is just 1, plus x times the derivative of v, which is just v prime. And we're going to substitute this expression into our expression for y prime. So if I were to replace this term, we'd have v plus xv prime minus 1 minus v equals 0. Now what we're going to do is we're going to expand this expression. Over here you get v squared plus xv prime equals 1 plus v. I'm going to clear this up to have more space to solve. Right? And so we're going to move the v squared to that side as well. So we get xv prime is equal to 1 plus v minus v squared. We get v prime, 1 plus v minus v squared. You get v prime is equal to 1 plus v minus v squared over x. And notice that v prime is just dv dx, so we can rewrite it as this, dv dx is equal to 1 plus v minus v squared. That's the squared over x. And this equation over here is the equation that we already know how to solve. It is a separable equation. So due to the fact that this integral is a lot more tedious than I thought it'd be, we'll skip solving this integral for now and we'll do a much more doable problem. So the problem we're going to solve in its entirety is going to be the following problem. Xy prime equals x plus y. Right, so how would we do this? Well, there's a lot of x's in this term, and a substitution that looks like we could make is the substitution v equals y over x. So we're going to divide everything by x first to get y prime equals 1 plus y over x. On the side, x. On the side we're going to make our substitution v equals y over x. We're going to cross multiply to get y equals vx. And we're going to take the derivative of y implicitly with respect to x to get y prime is equal to x v prime plus v. And notice over here we're going to make our substitution. So we're going to get x v prime plus v is equal to 1 plus v. Notice that the v's cancel. So over here we're going to have x v prime equals 1. Bringing that over here, we're going to get dv dx is equal to 1 minus x. 1 over x, my bad. 1 over x. And now what we have to do here is we just have to apply separation variables and just integrate. So I'm going to clear this board real quick and we're going to integrate this expression on the side. And so our expression we have is dv dx is equal to 1 over x. Separation of variables allows us to do dv is equal to dx over x. The integral of dv, or the integral of not 1 with respect to v, is equal to the integral of 1 over x with respect to x. Let's fix that integral sign. Right? And so we know the integral of the left-hand side is just v plus a constant c1. And the integral of the right-hand side is just ln of x, absolute value of x, ln of absolute value of x, plus another constant c2, and we're going to call that combined constant c. So our final equation is v is equal to ln of x plus some constant c. However, we're not done here, as this is in terms of v. We're going to have to back substitute our substitution, which we claimed earlier was v equals y over x. So we're going to have over here y over x is equal to ln x plus c. And we just multiply the x over to get our final answer, y. So our final answer will be y over x is equal to ln x plus c. We're going to cross multiply the x over to get y is equal to x ln x, absolute value of x, remember that, plus cx. And we can't combine this thing over here because x is a variable, c is a constant, and we don't have an initial condition, so this is our answer. So that is the substitution method in a gist. Essentially, what's going on is first, you'll identify and make a substitution. 2, you'll isolate whatever the derivative is. You're going to be d of some function with respect to x. And third, you're going to apply separation of variables. And that is how the substitution method for a first order linear differential equation works. Thank you for watching this video. I hope you learned something new today, and happy studying.